You all had a good lunch and you rested a little bit from this morning's exciting new information that you got about diversity of software and diversity in ecosystems and so on. And I think most of the afternoon is going to be devoted to diversity in groups of humans and other animals. And I in particular will be talking about diversity in human teams. And when we talk about diversity, we can consider at least two different kind of versions of diversity. One is this diversity of personal characteristics, and Scotty Page, who is going to talk to us later this afternoon, has a good name for it, which is like identity diversity. I just didn't want to put it right on the slide so that Scotty thinks, you're just copying everything I'm going to say. So anyhow, it's a diversity of things, diversity of team members when it comes to gender, age, race, ethnicity, and so on. And then another aspect of diversity is diversity of solutions or approaches to the problem that people have. Maybe decades of research in psychology, organizational science, and so on have been done on whether this diversity actually improves group performance. And the results are mixed. At least when it comes to diversity of personal characteristics, they sometimes translate in better group performance, and sometimes not. They do translate in better group performance when they affect diversity of solutions. Diversity of solutions, on the other hand, is often found to improve group performance, especially on complex tasks. When it comes to diversity of personal characteristics, whenever it can then lead to this better diversity of solutions, it will actually produce better results. So here is just one recent example of how quality of Wikipedia articles depends on the diversity of political opinions in the group of editors that author this article. And it actually increases. So the more polarized the group of editors is, so the more diverse people are in terms of their political orientation, they produce better articles, especially in the realm of politics, but also when it comes to science and social issues. However, these editors have the luxury of all being in their separate rooms and only communicating perhaps through their discussion board. And we all know what happens when you put radically opposing people with different political beliefs in the same room. Things can become tense, and that is this drawback of diversity of personal characteristics that has been observed, that the social emotional cohesion in teams, the interpersonal attraction can decrease when you have very diverse teams, at least at the beginning. Later on, people kind of get used to each other, and then this can lead to lower satisfaction, higher turnout, and so on. So the question is, then, how can we promote diversity of solutions? And that's the kind of diversity where I can really walk in this room like it's like a soccer field. I go from one to the How can we promote diversity of solutions in organizations? And of course, one way is to increase the diversity of personal characteristics. To the extent that they are correlated with diversity of solutions, this will help. This is a long process. For instance, some colleagues also related to the Santa Fe Institute have conducted a study on gender parity in computer science field among computer science faculty. And they looked at what point will there be 50-50% of male and female faculty in the computer science field in the US. And that's 2075. So it's going to take a bit because of various societal factors.
Sorry.
Yeah.
As someone who's lived in those departments, it's not just how fast you hire them,
Mm-hmm.
it's how long they stick around.
Yeah, which is another favorite topic of mine. How can we increase kind of the friendliness of workspace for people with different family needs and so on? Where,
with all due respect to Aaron, it's just there's two variables in that equation.
right, there are various things. I should say I should thank to the director of our institute for promoting all kinds of diversity at the institute and helping us all to find not only work but also work-life balance. So that's really great developments at SFI in the recent years. So aside from increasing diversity of personal characteristics, how can we promote diversity of solutions? Are there other ways? And here is where this the research we do on network science, on collective problem solving, on group dynamics come into play. And we actually have found, we and others, a number of factors that, aside from personality characteristics, can promote diversity of solutions in an organization. And I'll be talking about 5 of them, but they're all kind of interrelated. One is team size. The other is decision rules and network structures in teams. Then I will touch on the value of harvesting local wisdom of crowds rather than expecting that everybody is expert for everything. And finally, I will touch on this issue of safety versus threat and how that affects diversity in groups. When it comes to team size, so imagine that you are in charge of designing a committee or a team to solve a problem in your organization. The question is how large should this team be? Should it be a small team? Should it be a larger team? Old work by Francis Galton, and I'm sure also Scotty will talk about, has found that larger is typically better. That everybody knows the story of the ox, where people on a particular farm fair were asked what is the weight of this dressed ox. And the average of 800 guesses was very close to the actual weight of the ox. So whenever we have this kind of estimates of quantities, larger group is always better. And Scott has developed a whole mathematical background of this and explained why this is so. But now imagine another kind of decisions. And this is after all the deliberation that we did, after all the estimates that we produced, are we going to go left or right? Are we going to invest in this option or that option? This is a different kind. So this is a decision between two or more discrete options. And this has been studied by an even older guy, Marquis de Condorcet, in 1700s. And here, a larger group is actually not always better. Let me show you how this works. So here on the x-axis, we have the accuracy of average member in the group. And when it's above 0.5, that means that the task is relatively easy because average member's accuracy is larger than chance. When it's on the left-hand side, these tasks are relatively difficult because the chance is less than 0.5. You might wonder, what is this task for which performance is less than chance level? Think of last elections, 2016 elections, where most experts were wrong. So the accuracy of an average expert was less than 50%. So now what happens here is, the interesting thing is that when the tasks are easy, then larger group is better. If you take a group of, in this case, 9 people, and then take majority decision about what is the correct option, then you will increase the accuracy compared to the individual, to average accuracy of a person in a group. Larger group will start with average member accuracy of 70%, and by just taking majority rule, it will bring it up to an average of 90% accuracy. So, and the larger group, the better. Smaller group will have smaller increase in accuracy. So from 70%, a 3-person group will have close to 80% accuracy. But then the things flip on the other side of the graph, where a larger group is now more likely to agree on a wrong solution. And the smaller group now has a higher chance to agree on a better solution. So lower chance of a wrong decision. And how does this relate to diversity? So why is this happening? It is because smaller groups are simply more diverse. Their decisions, the decisions that they produce will be more diverse over time. So here is a little example. Imagine these 2 tasks that we already looked at. So one easy task where average member's accuracy is 70%, and the difficult task where it's 30%. The large group on the easy task will be very often correct, and will only in a few cases make wrong decisions. The small group will also be more often correct than wrong, but they will more often have also wrong decisions. However, when they are facing difficult tasks, now it is better to have a small group, because just by statistical chance, with no other differences between these groups, a small group will more often stumble on a good solution. So you will have now a small group being sometimes correct and more often than the larger group. Okay, all of this is, old theory from 1700s. I'm not saying anything new. But these are the results for a single task. So if you know in advance whether the task that your committee is going to face is going to be easy or difficult, then you can say, okay, for easy task, I'll have a large group. For a difficult task where the chance of failure could be high, I'll have a single person. I'll just pick randomly anyone in this room and let them decide. However, most committees are established to last for a while, so they need to solve at least 2 tasks, 2 or more tasks, hire several people, fire several people, make decisions about several investments. And the question is now, what is then the best group size for such tasks? Again, we can look at a combination of easy tasks and difficult tasks. Let's say that a group faces some easy tasks where average member accuracy is 70% and some difficult tasks. And for the sake of argument, let's say that they're experts, so they have a little bit more easy tasks than difficult tasks. And now we can look at how accuracy of group majority, which is on the y-axis, changes with the increase in group size. How much do we gain by adding more people to the group? And this red line shows how much the accuracy on easy task increases. As I showed in the previous tasks, this accuracy quickly reaches 100% as you increase the group size. The larger the group, the higher the accuracy on easy task. At the same time, the accuracy on difficult tasks decreases and will reach 0. If you have a large group and tasks are difficult, they will be wrong every time. So on average, you'll have a slight increase in group size with a slight increase in accuracy with group size, which will then stabilize at the proportion of easy tasks, the 60%. So you will never be better than 60%, the proportion of these easy tasks, no matter how much you increase the group. But in this case, at least the group size, that's kind of where you achieve maximum accuracy, is around 35 people. But now the question is, okay, what if you are lucky, and I call this neutral environment. What if you're lucky and you have something that I call friendly environment, where you have good experts or you have relatively easy tasks. And so now easy tasks are answered by 80% of your members correctly, and difficult tasks by 40%. So there is kind of a symmetry around the chance point. Easy tasks are quite easy, people are good. On difficult tasks, they are not so bad. Now here's where something interesting happens. If you look at the average accuracy of group and how it changes with the group size, it actually reaches the sweet spot between 5 and 9 people, 3 and 9 people. So if you have a group of highly qualified experts like you are, and you're going to face mostly easy tasks, but sometimes there will be 2016 election or 2000 election. There will be something that will put you off. Then it's actually better to have a moderate size group, or from 3 to 9 people usually, depends on the specifics. Because on easy tasks, you will quickly reach the saturation with the increase in group size. But with difficult tasks, this drawback of a larger group will fall more slowly. And so here's the sweet spot. This is what I call friendly environment. And then, of course, everything has a flip side. So you also have unfriendly environment where your experts are not so good or tasks are really, really difficult. Then in this case only, it's best to have as big a group as possible. The question is now, of course, what is the environment that most expert groups face? And of course, we cannot make the complete survey of all tasks that everybody ever faces, but we made some investigations of 3 types of tasks. Ones are election forecasts, and we used data that was accumulated by one political scientist, Grefe, in 2014. He was looking at how accurate were experts in predicting political elections, US political elections in different years. And we wouldn't call them political experts if they didn't predict most of the things correctly. So there are some years they were really good, but then there were some years like the 2000 where at least official result of the election was not what they predicted. And so now you can look at how this looks. What is the average percentage correct on easy task? It's close to 90%. Average percentage correct on difficult tasks, this below chance, was 34%. And so then if you plug it in the same analysis that we had in the previous slides, actually the best group of political forecast, but this group size of political forecast is only 5. And we can do a similar thing for groups of doctors, because there is data on how likely is that different diseases will be diagnosed correctly. And so now one can imagine a group of doctors that's diagnosing many different diseases, and some they diagnose correctly, some not. And luckily they do diagnose correctly most of the diseases, but some they get wrongly most of the time. And so the average medical team size is around 11, according to this calculation. And then even when it comes to economic forecasts, if you look at forecasts by the Fed and their advisors about whether unemployment, inflation, or economic growth will increase or decrease in the next period, then again we find that they are good on some topics, not so good on the others. And so we find this average group size was 7. So exact group size will of course depend on the group, on the task, and so on. This kind of just to demonstrate that it seems like when we are dealing with teams of top experts, that it might be the case that oftentimes they face relatively easy tasks most of the time, and sometimes they fail. And for these situations, moderate group sizes are actually good, and that's because of the pure statistical effect that smaller group has more diversity. We can also apply the same logic to think what would be the best group size if part of the group is following an opinion leader. Let's say that in your company, there's a part of the team is always going to vote with CEO, whatever, or with the current authority in their field, or will read the latest article in New York Times and then vote in that way. So now you have correlations in the group. You can analyze it in a similar way. So if you have accuracy of average member of 70% on a particular task, and the opinion leader, the New York Times article, the CEO, is the same, has the same accuracy, so it's not any better. It's just that people in the group will vote with this opinion leader. Then you can calculate again how this translates in the average group accuracy. And so here is one thing to observe is whenever opinion leader is correct, then all of his followers will be correct. Whenever the opinion leader is wrong, all of his followers will be wrong. And so basically you have a situation that when leader is correct, for this example, it's 82%, it's an easy task. When leader is wrong, it's a difficult task. And so then, in many circumstances, you will find that, again, the moderate group size is better when you have correlations in the group. So this kind of same framework explained these things. But the general point of this first part was that when it comes to team size, unexpectedly smaller team size can be better because of increasing diversity. So without any other diversity of group characteristics or anything else, so this is just a statistical principle. Questions? Yes?
Do you take into consideration how members of the group are interacting, or is that just something that you leave aside?
So we looked at the idea is that they are making majority rule decision by majority vote, and we do allow that they could interact before and have correlated opinions. So this was part of this analysis, but also we can analyze in different ways. And so this will not cancel this overall effect that the smaller group can be better with this particular combination of tasks. Yeah. It will just flatten the whole things out. So the more they interact, the more correlated they are, the less is useful to have larger group because they all vote like one. Yep.
Just out of curiosity, why did you have 60% easy tasks instead of 50-50?
I could have had. It will change what kind of environment this is. I was using an example that we find in the empirical world where most of the tasks are easy rather than difficult. But it could have, so we did calculations for all of the combinations of these parameters, and basically what you find is that you have these three types of environments, what I call friendly, where tasks are relatively easy and difficult, not so difficult, where moderate group sizes are best. Neutral, where it pays off to increase the group size to a certain level. And this unfriendly, where it's just so bad that you can just keep on adding people and have a really large group and you're still not as good. Mm-hmm.
So why do you assume smaller groups have more diversity?
So I think it's a simply statistical thing. So let's say that you want to see, you have a biased coin, but you don't know how much the coin is biased or whether it's biased. So you can flip it 3 times or 10 times. If you flip it 10 times, you'll discover the bias of that coin and say, yes, it is biased or it is not biased. If you flip it 3 times, it sometimes may appear biased, sometimes not, depending on different of these instances. So just you don't have such a good idea of what the truth is. And because you don't have such a good idea of what the truth is, you are going to make some mistakes. And in some cases, this is going to help you.
This could be, pick up on your question, I was having the same one. Your illustration suggests there is some social identity diversity there, but it could be 3 white women.
Could be.
But that doesn't necessarily make it more diverse.
So the only thing that, it is a different mechanism of diversity. Yeah. So the only thing that matters here is what is their average accuracy. Whether they're on average accurate 70% of the time or 30% of the time, it doesn't even matter how diverse they are to an extent, except if one of them is always wrong, then it changes the calculation. But otherwise, so this is kind of, let's say that you are stuck with 3 white men and you want to make them more diverse. Okay, you're stuck with 9 white men. Yes. Just cut off 6 randomly.
It's just a hypothesis.
But it's this, you're stuck with 9 same people. What are you going to do? How to increase their diversity? One way is to just pick 3 randomly and let them make a decision.
Of that group.
Of that group. So, if you cannot change their other personal characteristics. So I'd say this is kind of going beyond the personal characteristic.
Yeah.
Mm. Yeah.
This is diversity in terms of accuracy.
Sorry?
This is diversity in terms of the accuracy of the solution?
Yes. So maybe your next question is, this assumes that we know what is the correct answer. Exactly, yeah. So this is for answers that have some kind of measurable, knowable solution. The whole other bag is the realm of preferences and multidimensional problems, which is another can of worms. Mm-hmm. Yep.
How could you solve for the variables associated with the terms that you used of easy versus difficult,
Mm-hmm.
and then friendly versus maybe not so friendly? Because those seem very subjective,
Mm-hmm.
and they are big components in how you got to your conclusion of smaller actually creates more diversity.
Mm-hmm.
To solve for those.
So friendly is just my label for the situation where average individual accuracy on this kind of tasks, on easy tasks, is close to 1. And where average individual accuracy on difficult tasks is close to 0.5. That's all. I just labeled it friendly because.
That's fair. That's fair.
Yeah.
That's fair.
Thank you. Okay, I have maybe you had there was one more question, and then I should move on.
Identify experts that are only 30% accurate. I mean, a little bit about methodology here, because
You don't identify them.
okay.
So you just have your team, and on average, sometimes somebody will be correct, another person will be correct. On average, they're 30% correct. That's all you need to know. So I'll proceed. Okay, so in the second part of my talk, I'll talk about. Okay, this is another way to kind of make diversity, to increase diversity without actually changing personal characteristics of people. And this is by looking at what decision rules group use to make decisions, and how are they organized, how do they communicate. So what is the network structure in the team? Now to explain how this works, I will enlarge a little bit our concepts of the tasks. For now, we had a flipping coin, or we had decision between 2 or more courses of action. Now we will have a task that's maybe more realistic, and this is, let's say that you need to design something, you need to design a product or solve a problem. And these tasks could vary in complexity. And this is kind of an old way of presenting this at the Santa Fe Institute, to present task complexity as a landscape. So you have, this is the landscape. So you have all possible options or solutions to the problem, and you have their payoffs. And we say that the task is simple when there is a single or a few options that have the highest payoff. And they are all kind of grouped together. So once you're here, you will naturally come to this option with the highest payoff. This is an example is, if I tell you, design me a drinking vessel. So across human cultures, all over history from 1,000 years ago, it's a cylinder which is closed on one end. This is the drinking vessel. And this might be an optimal solution for this problem. And let's say that this is our standard cup, and these are all these other shapes with openings on other sides and so on. But there are also complex tasks, such as designing a car. And deciding what technology should I put in this car, how should this car go. I could decide to make a standard car driving on gasoline, or a hybrid, or an electric car. And all of these are decent solutions. They have their payoffs. But once you invest in one of them, you are making it less likely to reach maybe perhaps an even better solution elsewhere. So this is a schematic representation of a more complex tasks, where you might want to explore a bit more before you zero in on a particular solution. Now, what is then the role of diversity in solving these simple and complex tasks? And one aspect of diversity will be promoted through network structures. So how often people communicate in the team. In some teams, they could be tightly connected and communicate often, and everybody with everyone. This will contribute to faster information spread, so whatever they thought of, they'll communicate to each other. But then this will also contribute to a lower diversity of solutions, because they will see solutions of each other and tend to copy or tend to zero in on a solution that currently seems best. imagine in contrast that, let's say, members of this table, that you're not communicating everyone with everyone, but you're the two of you are communicating, the two of you, and so on, like a ring. This will, here now you have a slower information spread, which will then result in more diversity of solutions. And then we can also imagine different decision rules that groups are using to make decisions. So let's say that you meet every now and then, your committee meets, and they are discussing what has everybody come up with and how to proceed. Now, you can make this decision by following currently best member. Let's say that you have currently the solution that seems best, and we are all going to abandon what we are doing. We are going to go to your region of the solution space and explore from there. Or we can say, no, in this table is saying, no, we are going to take majority rule. We are going to only follow a solution for which at least, okay, you're an even number. Okay, at least more than half is agreeing that it is a good solution. Or we can follow other rules. There are many others. You can follow the leader. You can follow a random member. Or you can just not follow everyone and just let everyone individually, this individual learning, individually developing a solution. And then later on, after everything is done, see which one is best. And again, here in decision rules, you have similar thing like in networks. If you follow a currently best member, every time you will be able to reach some decision. This is the information about currently good solutions will spread faster, which will produce less diversity. If you use majority rule, then you will not always be able to make a decision, because oftentimes not everybody, not at least half of the, or more than half of the group will agree on what's the best solution, which means that you will, go back to your offices, develop more, explore more on your own, and then come back again. So now you'll have slower information spread, and the result, you'll have more diversity. And so now we can look how these decision rules and network structures interact with the task complexity. And this is what we did in some series of simulations. And here are the results, so bear with me, it's kind of simpler than it looks. But basically, the x-axis, you have time. So this group is now meeting over 200, it has 200 meetings. They're making decisions about a particular task. And in this case, this is a simple task like designing a drinking vessel. And different groups in this experiment are using different decision rules. Some are using this best member rule. And also we looked at the influence of the size of the group. Some groups are small, have only 3 members. Some groups are larger, 9 members. Then you have other kinds of groups that use majority rule. And then you have people who are completely individual, they never share. And then people who copy randomly. And here on the y-axis, you have average performance of these different strategies, of groups that use different strategies. And in this case, when we have a simple task, the best member rule, this fast rule that promotes less diversity, is the fastest to reach the optimal performance, so the top performance. They will find this drinking vessel, this cup, the fastest. The others will also find it, but a little bit later. And why is this? And it has to do, everything has to do with diversity of solutions. So the fastest group, the ones that reach the average performance fastest, will drop immediately in the number of unique solutions over time. They will quickly zero in on the best, most promising solution and pursue it. Those who use slower strategies will linger on longer on non-profitable solutions. Now, everything changes when we have complex tasks, such as those designing a car, or basically most of the things that we need to decide in daily life. Now, groups that are using this majority rule in small groups, again, we have our small groups, this one, is going to reach highest average performance. While the best member rules, these red lines, they are going to never reach. They are going to reach some intermediate solution and just get stuck there. They are not going to explore enough of the problem space. And this is happening because, again, there is a diversity, the differences in the speed of information spread and the speed in which diversity of solution changes. And so you see, again, these fast rules, the best member rule is quickly decreasing. They quickly find something that seems reasonably works reasonably well. They all agree about it, and then they're stuck in that part of the space. They drop their diversity too soon. Those that are using smaller group size and majority rule, they're able to maintain their diversity longer, but then eventually still find a good solution and then agree about it. The individual learning rule is it has most diversity, but overall it achieves low result because somebody did find a good solution, but it never spread in the team, so the team doesn't profit. You know, the most interesting part that I thought of this research was that there is actually, it's not always more slower is better, but that there is an interaction with these decision rules with the network structure. The results I showed so far is for fully connected networks, for networks that everybody communicates with everyone. But now you can look at how these different rules work in networks that communicate less often. So in networks like such a ring lattice where only neighbors communicate with each other. And now we see that there is an interaction between the speed of the rule, the speed of the rule and the speed of the network. Fast rules work better in slower networks, and slow rules work better in fast networks. And now implication for the organizational kind of design is that if you're stuck with a particular network structure, so if this table really loves to sit together, they're going to talk all the time, you cannot stop them talking, then it's better to use a slow rule, such a majority rule. You're going to slow the decision-making process and still maintain some diversity before everybody jumps, on your solution. In contrast, if you have another table where people don't talk so much, they just talk to their neighbors, and you want to speed up their decision process and the spread of good solutions, then it's better to use the best member rule, which is a fast rule. So there is this kind of sweet spot and interaction of these elements. So in sum, for this part of the talk, basically there is this, the group performance and diversity will depend on decision rule and network structure in a way that fast rules will work well with slow networks, and slow rules will work well with fast networks. Before I go on, would you like to ask some questions? Yes?
So this is all based on a statistical model, basically, is that right?
Right.
Are you going to get to where you've tested it?
Yes, we are conducting experiments as we speak with kind of real people. And we would be very surprised if at least kind of baseline we don't see this. So since I'm a psychologist, I'm often frustrated with my own field that we are inventing labels for things that we're inventing cognitive labels, psychological labels, and explanations for things that are purely statistical. And then once we uncover this underlying statistical structure, that will enable us to relate these phenomena with fishes. Plants, other natural phenomena, which will then help us to understand the system better. And then from a psychological perspective, it will give us a baseline where we don't need any psychology and where do we need to go into psychological explanation. So I'm kind of happy with this. I'm happy that such a frugal statistical model would explain much of what seems more motivated by individual differences.
I guess because it's a statistical model and because I hang out at the Santa Fe Institute, which loves power laws, I kind of wonder if the distribution...
Is it the power law?
If the distribution matters, like if you're just assuming a normal distribution.
Yeah.
Because in a lot of cases, it seems like for the decision-making things, it wouldn't necessarily be normally distributed.
No, it does matter. So we were running complexity of the task using this simple NK model, and then you see this. You see certain. At first, the fast decision rules are better, and the fast networks, and then there is a slow decline in them. And as the task complexity increases, the slower network and slower rules become better. So yeah, definitely. I think the structure of the task is extremely important. It's often not recognized. And then, for instance, I was happy with this finding that decision rules and network structures interact, because there is actually a lot of disagreement in the literature whether teams should be more connected or less connected. Shall we make everyone talking to everyone, or shall we just meet occasionally and just talk to our neighbors? And there are some prominent recent papers in good journals saying one or the other thing. So it was not clear. But what this actually shows is that you need to pay attention to the rule that the group is using. And so if the rule is using a slow rule and in addition are communicating slowly, that's going to be not so beneficial. But if they are using a slow rule and communicating in a well-connected networks, that's going to be great. And so when we look at these past studies that disagreed, we think that this is the reason of the disagreement. And when you look closely, that some groups were using one rule and the other rule, and that the interaction explains that. Yep.
Yeah, no, I really like this idea to define the psychological as the residual deviation from
Mhm.
now. It's an interesting definition
Mhm.
of what an explanation is. But I was wondering, but maybe where psychology comes in is in the choice of the density, the choice of n.
Mhm.
That's psychological.
Mhm.
But then the dynamics sort of takes over. So it's not, you don't need the psychology to explain the outcome, you need to invoke the psychology to explain the choice of rule.
Of what, how is rule made? Yeah, that's you're completely right. So how groups decide how to decide, who is the leader, how do they decide what's good or bad, all these things are finer. But then also psychology in this, it did play a little role, is that we even thought of thinking about rules that people have used to make decisions, which is an old psychological thing. And so this kind of cognition did play a role in this sense. But then, yeah, there's all this richness in addition. Okay. Okay.
So, I'm just wondering if you've looked at the relationship between this way of looking at things and, you know, the way that I'm more familiar with it is thinking about it in terms of this trade-off of exploration versus exploitation.
Mm-hmm. Mm-hmm.
So kind of from like the bandit problem
Mm-hmm.
perspective.
Mm-hmm.
Because it seems like maybe what's happening with the fast rules or slow rules or fast networks or slow networks is changing that trade-off between how quickly
Exactly.
you explore versus how much you exploit.
Yes.
I just wanted to get
Yes,
that.
it is exactly that. That's the trade-off between exploration and exploitation, where here we decide exploitation maybe in a little bit unorthodox way, and that's exploiting the solution of your neighbors. So social exploitation, if you wish, versus individual exploration. But it's exactly that, yeah. All right, I'll go on to my next set of thoughts, and that's about exploiting the local wisdom of crowds. So let's come back to our elections that are always a good topic. So let's say that you want to somehow extract the wisdom of crowds regarding the result of the next elections. And you can ask this person on the left to integrate everything he knows about the elections, all the polls he has ever heard of, all the predictions of political pundits, knowledge about different states, and so on, and then make a prediction of who is going to win the election. Or you can ask this person to just don't think so much and just report what he knows about his or her friends, or his, in this case, his friends. So whether, if he has 4 friends, including him, who are they going to vote for? Are they going to vote for Hillary or for Trump? And this is exactly the idea that we implemented to try to improve the predictions of the last election. And we are encouraged with these results. We are now going to actually test it also in this upcoming election. So these are these 2 ways of harvesting the wisdom of crowds. One that has been often used in political, not often maybe, it has been used in almost every year of political polling in the last decades, 40, 50 years. And this is to ask people, what do they think, who is going to win the election? So not only who they are going to vote for, but who they think is going to win the election. One version of this question is, what is the percent chance that Clinton, Trump, or someone else will win the election? And oftentimes, this question is actually quite good, and it can predict the election winner as good or better than actually asking people who they are going to vote for and then averaging these intentions. But in these elections, it did not work well, because even people who were voting for Trump thought that Clinton will win. And probably because also there was this highly amplified predictions in the media that were giving high chances of Clinton winning. That was probably one of the reasons why this question did not work so well. These are the results of a poll with which we worked. They asked every week from July to October, who do you think, what is the percent chance that Clinton, Trump, or someone else will win? And so Clinton is always up to the very end. In contrast, you can also ask about the local wisdom of crowds. So ask just people, okay, think of all of your family, friends, and acquaintances that you are in contact with, any kind of contact with, email, personal, in the last month. What do you think? what % of these people is going to vote Clinton, Trump, or someone else? Now here we are avoiding this step of information being filtered through the media, and we are just relying on people's knowledge about their friends. And why did this occur to us? Because we have 10 years of research on how people make social judgments about their in social environments. And we figured from previous research that people are actually quite good in knowing what their friends think or do. Not the broader population, then they have some systematic biases. But your immediate family and friends, you have pretty good idea what they do, how they are. And so we were thinking, okay, maybe we can use this local wisdom of crowds to try to predict elections. And then we were also comparing this with the standard question of own voting intention. So if you do vote in election, what is the % chance that you'll vote for one or the other? And we posed these questions in 2 US polls and the French poll. And we just published these results. Basically, we get improved predictions. And I'm not going to bother with all the details. I'll just show some graphs from the US. So this is, so these are these people in this poll that I showed earlier that were asked every week to say what is the % chance that they are going to vote for Clinton, Trump, or someone else. And all the way up to the very last week before the election, they were saying that there is a higher chance that they are going to vote for Clinton rather than for Trump. But then when we asked the same people who they actually voted for, some of them switched and voted for Trump rather than for Clinton. But then if you look at their social circles over time, then you see this switch toward Trump already in September. So there is some, so it seems that they were not, when we were asking them about their friends, one worry is that they will simply report who they are going to vote for, giving the same answer. But there was a different information. There was additional information in the question when they were reporting about their social circles. And then again, the same people, when they were asking about who they expect to win, so these are the people who eventually voted for Trump, they were still thinking that Clinton will win up to the end. So this is a very short version of these results. There is much more. In France, in particular, we got really good results. But so the point here is that we were again diversifying the information. So we were relying on very local, information from every person. So it is as if you have a team in an organization to need to solve the problem, and you have a large body, you have several encyclopedias of knowledge that will help them to solve the problem. So do you give all the encyclopedias to everyone, or do you give one encyclopedia to you, and one to you, and one to you, and then you come up with more, basically will come with more diverse knowledge, and maybe you will reach a better judgment than if you all tried to understand everything. So it's only kind of, it's in a way promoting diversity of solutions that people come up with by relying on what they know best, on their immediate area of expertise, and then combining it. Questions about this before I go on? Right. So you can follow our work and see whether we are able to predict any state-level elections in November. Because one thing that we found out here is that we were able to improve predictions on the national level, but in particular when the samples in some areas were small, then the improvement due to asking people about their social circles were larger. So on the state level predictions, we got larger improvements. In state, for each state, we had relatively small samples, sometimes 30 to 60 people. And so when you ask people not only who they are going to vote for, but who their friends are going to vote for, you get much more information. And so we are, at least in that election, we were able to improve predictions. Anyhow, so that was this about local wisdom of crowds. And now we come back to that experience of safety or threat, and how group diversity changes when they feel that they are under threat. And what does this mean? Does this then improves or hurts group performance? So we know, again, from decades of social psychology that when group feels under threat, they tend to become more homogeneous, to have more similar beliefs, to group behind the leader, to police and people who have different opinions, to ostracize people who have different opinions. And this is a phenomenon that is observed over and over again. And one puzzling thing is that we still don't know whether it hurts group performance or not. You would obviously think, well, people are policing each other, ostracizing, they all have the same opinion. That cannot be good. We want diversity. But it actually, some studies show that it hurts, some studies show that it helps. It's not clear. So for example, the famous groupthink book by Janice have shown that when a group feels under threat, and they have low diversity of solutions, they can really come up with some bad decisions. But also, decades of military psychology have shown that more cohesive military groups who share the same ideology and the same idea how to defeat the enemy are better coordinated and actually better in military situations, at least when it comes to classical warfare. Perhaps it changes now. And so we are kind of exploring this a little bit just to see how ubiquitous is this change in diversity in groups. And we are now, because of the thread, and we were using one so far unexplored data source, for which everybody is laughing at me at SFI, and that's online discussions. So I'm very fond of reading comments of people in news articles online. So as you know, on many sites you have the function you can leave a comment on an article. And then you get all kinds of opinions from different sites. To leave a comment on an article, you need to log in with a particular fake username, which enables you to see how opinion of this particular person changed over time, whether it changed at all, and whether it changed because of the influence of other people in the group, of some current events, of a recent tweet of a major personality, or so on. Also, it is currently possible to basically gather a lot of these discussions from and we have years of data from different sites, different comments. And we just got an NSF grant to start also exploring this further, and there are many analyses one can do. But for the purpose of this argument, the first thing we looked at is how diversity of these comments changes over time when the group feels more under threat or less under threat. And to do that, we have, millions and millions of these comments. And so we use a very simple they call it word embedding algorithm, which basically transforms each word in an n-dimensional vector, where the numbers suggest how often this word co-occurs with other words, with some other words. The more similar these numbers are to another vector, the more often are these words used in a similar context. So for example, you can use this algorithm to then calculate what are the words that are similar to a word in a given body of text. And so you can look, for instance, what are the words similar to word evolution in the body of comments on Atlantic, more left-wing side, and Breitbart, more right-wing side. And so the most similar words to evolution on Atlantic are evolutionary, nature, genetics, and so on. On Breitbart, it's atheism, hypothesis, theoretical, and so on. So there is some face validity in this. So we use this method basically to transfer all these comments in numbers, and this also enables us then to calculate average diversity of comments over time, because not only that you can transfer each word in a vector, you can now in more or less sophisticated ways transfer each comment in a vector. And now you can calculate simple difference of different comments. So your comment has a vector of 100 numbers, and yours has another 100 numbers, and I can use some simple measure of distance to see how different you are. And then average it over all the thousands of comments in a particular discussion to see what's the average diversity of comments in that discussion. And then we can look at how it correlates with the threat that the group seems to be experiencing at the time, measured just as a relative proportion of words that we identified are signal that the group feels under threat, things like threat, danger, protect versus success, victory, win. So threat, danger, protect versus success, victory, win, and so on. And so what we see, okay, so these correlations to more natural sciences among you look weak. But to me as a social scientist, a correlation of 0.3, which is this, is the maximum I can ever hope for achieving. Yeah. So, it's fine. But moreover, so not looking at this noise around these lines, is that the trends are similar on Atlantic and Breitbart. You cannot get much more different than audience and the structure, the structure of readerships of these two sites. So so here on the x-axis, you always have proportion of words indicating threat. Here you have low threat. And this is proportion of words in high threat, and this is diversity of comments. So in this top part of graph, we have a positive correlation of diversity when the words indicate, when they seem to be discussing something that's low, not so threatening.
But is what the threat is different? Is the definition of the threat
we used
that underlies that?
so it's mostly the same, but we did allow that there are some differences in exact word that they use as something threatening. So Breitbart use win and winning a lot when they don't feel threatened. Well, Atlantic uses something else. But most of the words overlap that indicate threat on different sides.
Can you explain the axes?
Sorry?
Could you explain the axes?
So that's a proportion of words that indicate high or low threat in a discussion. Each of the dots is a discussion. One thread could include thousands of comments. And then this is it's a very small proportion. It's a proportion of words that indicate that the topic that's being discussed is threatening. And then on the y-axis is diversity of comments. So basically, the more threatening words, the lower is diversity of comments. The fewer threatening the words indicating the opposite, safety, winning, and so on. Then we have higher diversity. Okay, so this was just a demonstration that this seems to happen in the real world. But what does this mean for our teams and for performance of groups? This is something that we are going to explore further, but I would just like to connect to some of the first complicated graphs I've shown. And that's okay, so when could we expect that more or less diversity will help or hurt performance? Well, it will depend on the complexity of task. In simple tasks, as we've seen, the strategies that promote low diversity of solutions are best. So this best member strategy, if you remember, was best in reaching the highest performance very fast. And it did that by decreasing, by zeroing in on a particular solution very fast. On the other hand, these slower strategies were also pretty good. I mean, they did reach highest performance, only less quickly. Now, when it comes to, when it comes to complex tasks, now we have a larger difference between solutions that, between strategies that were promoting more or less diversity. So when we look at how perceived safety or threat will affect group performance, then we might reconcile this literature, which cannot find whether threat is good or bad for performance, by looking at the type of tasks that the group need to solve. When we have low threat, we have relatively high diversity, which is fine for simple, it is really good for simple tasks, and it's fine for complex tasks. But when we have high threat, then, and lower diversity, it is not going to hurt simple tasks, but it is going to be really bad for complex tasks. So basically, in conclusion of this section is that diversity may or may not help, depending on the type of task the group will solve. And then if the group feels threatened, this may or may not hurt performance, depending on the type of task that the group needs to solve. So I will conclude here with just a summary of everything that I've said so far, and overall, basically that we can promote diversity in solutions in different ways. And typically it is discussed as that promoting diversity of solutions should be through increasing diversity of personal characteristics. And this is good. It takes time, but this is definitely one good solution. But then there are other basic, more statistical methods that one can glimpse when looking at overall in the kind of science of networks and group dynamics and collective problem solving. And this is by manipulating team size, by using different decision rules and network structures, so using slow decision rule and fast network, by using local wisdom of crowds, so relying on the local and individual expertise of people and then integrating it rather than trying to make everyone an expert, and by promoting safety in a group, so by not making your team feel threatened. Because when they feel threatened, they're going to show this tendency towards more homogeneity of solutions, towards kind of policing of different solutions, towards joining behind a common leader, which might hurt their performance on complex tasks. So kind of promoting safety in a relaxed working environment where everybody's friendly might be helpful. So this is all I had to say. Thank you very much. I'll take questions.